Okay, in the previous video, we discussed how to implement an undirected graph using adjacency matrix. So today we can move further. Okay, so today's topic is directed graphs by using directed graph representation by using adjacency matrices. So of course we can represent a graph by using GVE structure when it comes to mathematical ways. So V means basically set of vertices and E means a set of edges. So according to this representation, 1, 2, 3 are the vertices, and what are the edges? 2 to 1 is one edge. So let me use my pen first. 2 to 1 is one edge, and 3 to 1. 3 to 1 is another edge, and 3 to 2 is another edge. So likewise, I said before, the edge should be represented as out degree and in degree. It comes to directed graphs, this is pretty much essential. If you are representing this as 1 to 3 instead of 3 to 1, then there are differences. Okay, there are differences because it is directed. It represents some direction. So if you are representing this 3 to 1 as like this, then it means 1 to 3, not 2, 3 to 1. Okay, that's why it is very essential to have a clear idea about how to represent an edge by using this manner. So it is pretty much simple, but you have to clearly understand it, otherwise maybe later you will be problematic, you will face some problems. So yeah, like in a undirected graphs, you can represent that directed graph by using adjacency matrix. Only difference is it could be symmetric, either it could not, most probably couldn't be symmetric. Most cases it is not symmetric. Okay, since it is directed, in most cases some edges must be contained undirected behavior undirected edges, but many edges would be directed. Therefore, it will be in. It will not be in symmetric manner, but it could be in symmetric manner if all the edges are undirected, but then it is not a directed graph, it is simply an undirected graph. So basically what you have to remember is, when it comes to directed graphs, its metric representation is not symmetric. Right? This is the only fact actually. All the things are same. So now we can implement a directed graph using adjacency matrix. So this is pretty much same like before, only a very few changes will be occurred. Okay, so this is the previous code I coded before. So if you have the previous code, what you have to simply do is just basically remove this line. It is simply like that. But if you are a new person, then I'll explain how we represented this coding as well, but very quickly. Okay, so this is our library. This is our maximum definition. This is our namespace and int name. This is our main function, and we need adjacency matrix, max, and we need three functions. First, to initialize matrix, so we need one parameter, and void add edge, so we need two parameters, and we need another function to display mat. We need only one parameter. So in here we need two for loops. For int I equals 0 to so on up to b I plus plus. Likewise int j from 0 so on up to b j plus plus. Adjacency matrix I j equals 0. So at the sorry, so at edge basically u v equals 1. Displaying is simply we can use this for loop as well. Only difference is we need another for loop over here. I can use this as well. So it begins with 1 so on up to v and c out tab space I and c out and there. And over here we need 1 and 1 equals so c out this one, then a tab space this one, and before that we need to show our I and maybe tab space, then c out and there. So let's define another variable like vertex 3, then another edge, then another edge, another function we can use what is the add edge. So what are the edges that we can add? 2 to 1, 3 to 1 and 3 to 2. So 2 to 1 and 3 to 1 and 3 to 2. Now we can display our matrix by using our defined vertices. And before that we can initialize our matrix as well. It will be easier for later. And return 0. So let's compile. No errors, then execute. Okay, so I think our adjacency matrix is successful. Let's look out the matrix. Okay, so 2 to 1 has been represented, 1 to 3 is there, 3 to 2 is there. So this is how we represented a directed graph by using adjacency matrix. It's basically exact same code we used in the previous one. Only difference is I removed a line from here. If I do it like this, then this is the previous code we have written, then it represented the undirected graph. So in order to represent a directed graph, only difference I made is to remove this line. That's why I go through this code very fast. If you couldn't get the idea, then it is better to watch the previous video because I explained everything over there. I just coded very fast in here because it is exact same thing what we have discussed earlier. Only difference is I removed one line from here. Okay. So this is how we represent directed graph by using a adjacency matrix. So thank you.